Okay, so I'll be teaching 4.3 triangle trigonometry. And first thing you need to know is SOHCAHTOA, and also that from a reference angle as an x, across from it is opposite, adjacent is adjacent, and then the long one is a hypotenuse. So for sine, it is opposite over hypotenuse. For cosine, it is adjacent over hypotenuse. For tangent, it is opposite over adjacent. Okay, now cosecant is the opposite of sine, and secant is opposite of cosecant, as well as cotangent and tangent. So cosecant, hypotenuse over opposite, secant. Okay, now secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. Okay, and then for this example triangle, you have to pick a letter and set x as in degrees, so then you can determine sine, cosine, or tangent. So first we'll solve for a, x there. So solving for sine, you go opposite over adjacent. Okay, now solving for sine of a, we're going to go opposite over hypotenuse, which is 7 over 25. Cosine, adjacent over hypotenuse, 24 over 25. Tangent, opposite over adjacent, 7 over 24. And for sine of b, the opposite letter, all you have to do is flip them, just like cosecant, secant, and cotangent. Flip them, and they will equal the same set of values. So for sine of b, it would equal cosine of a, same as cosine of b and sine of a. Okay, so now for part 2, to determine if it's a 90-degree angle, we look at if the sine of a is equal to the cosine of b. Just like here, we flip them and they equal the same. So if they equal the same, then all you have to do is plus them to get 90. So sine of a, opposite over cosine, is AC, a divided by c. And then cosine of b, adjacent over hypotenuse, a over c. So angle C is 90 degrees. Now here are cofunction identities for an acute angle. Sine of A equals cosine, parentheses, 90 degrees minus A. Cosine, same thing except these flip. Cosecant and secant flip, just as right here, same as right here. Now for part 3, these are examples. So we'll go ahead and redo these for practice. Okay, so since it's cosine, we're going to do the opposite, which is sine. And 52 equals A. So all we have to do is plug in. So we do sine, because it's the opposite, it's said right here. So 90 minus A, which is 52. So that math equals 38. So sine of 38 degrees is your answer. Problem B. Tangent, so we do cotangent. 90 minus 71 equals 19. So cotangent of 19 degrees. Secant, which would be cosecant, and is 90 minus A. So, but this one is different. So we do 90 minus, still A, minus parentheses, 24 minus x. Now we simplify, which is 66 plus x. So 66 plus x. And this is your answer, finalized answer. Okay, now to solve for theta, this little symbol is theta, which we use for angles of reference in triangles. Now, because cosine and sine, which are equal to each other, as we did A plus B equals 90 degrees, that's what we're trying to do right now. And we'd set, so this would be A, this would be B, set them equal to each other, and then, or plus them together to equal 90. So we have theta plus 4, plus, because of plussing B, 3 theta plus 2, equaling 90. Now we just simplify. So theta plus 3 theta is 4 theta, 4 plus 6 is 2, or 4 plus 2 is 6, I'm sorry, equals 90. Subtract 6 both sides. 4 theta equals 84, divide by 4, theta equals 21 degrees. So saying that, this would be 21 degrees. Now over here, same thing as follows, is this goes down for A, plus in the middle, this goes down here for B, set it to equal 90. So it would be 3 theta equals 90 because the negative 18, positive 18 cancel out. Divide by 3 both sides, theta equals 30.
All right, and now this is Joel explaining the rest. So below we have here a triangle, a right triangle with 2 equal length sides, right here and right here. It says if each leg equals 1 unit, so we put 1 unit and 1 unit, then we have to find the measure of the hypotenuse. Hypotenuse is right here. So what we do, if you have regular right triangle, you take one side, you square it, so we have 1 squared, and then you take that plus the other side, square that as well, 1 squared, so that would equal x squared. So now we have 1 plus 1 squared both. And so now, since we have 1 squared plus 1 squared equals x squared, we have 1 squared, which is equal to 1. So 1 plus 1 squared, which is also equal to 1, plus 1 equals x squared. So then we have 2 equals x squared. And so we have to find x by itself. So we have to square root this, and whatever we do to this side, we have to do to this side as well. Square root that. There's no perfect square root for 2, so x will just equal the square root of 2. So we put this into our hypotenuse as our length, and then that is how you find that. All right, so here we have an equilateral triangle, which means all sides are the exact same length. And as here it says, all the sides are equal to 2 units. So 2 units right here, 2 units right here, and 2 units right here. And then so it says construct an altitude from the top angle right here, the top angle right here, to the base, which is right here, the base of it. Then we have to find each side length of the right triangle. So we're going to cut it in half pretty much. And then we have to find this length, and then this length. So what we're going to do is we already know that this is equal to 2. And then if we cut this in half, 2 divided by 2 equals 1. So we have 1 down here. So we have to use the Pythagorean theorem to have, well, since this is hypotenuse, this will be c, because the Pythagorean theorem is a squared plus b squared equals c squared. So as our hypotenuse equals c, right now we have a squared plus b squared equals 2 squared. So then we can just plug the 1 in for a or b. So we have a squared plus 1 squared equals 2 squared. So then after this, after we simplify all of this, we have a squared plus 1 equals 4. So to find this length, we have to put a by itself. So we minus 1 from that side to get a by itself. So a squared would equal 3. And to get a by itself, we would have to square root this side, and whatever we do to this side, we have to do to this side. And since there are no perfect squares for 3, a would equal the square root of 3. And then we would insert this into our length right here. So you have square root of 3. Okay, so we're given theta, and then we have to find sine, cosine, tan, cotangent, secant, and cosecant of theta. So we are given theta equals 30. So we have to look back into our triangles. So we'll look at this one first. This is 90 degrees because it is a right angle. So then we have to find 180 with the remaining angles. Okay. So we are given theta. We have to find sine, cosine, tan, cotangent. You have to find cotangent, secant, and cosecant. So what we're gonna do, we're gonna use our angles that we have here. We used these angles for the reference to find sine, cosine, tangent.
So here we have the triangle and the given lengths and angles to solve for theta of 30 degrees, 45 degrees, and 60 degrees, and also define sine, cosine, tangent, cotangent, secant, and cosecant.
Hi, Miss Eddie. And for trigonomic identities, the opposite of sine would be 1 over cosecant. The opposite of cosine would be 1 over secant. The opposite of tan would be 1 over cotangent. And so somewhat like up here, the opposite of cosecant would be 1 over sine. The opposite of secant would be 1 over cosine. And then the opposite of cotangent would be 1 over tangent. And then for quotient identities, tan is different from up here, so tan would equal sine over cosine, and cotangent would be different from up here, so cotangent would equal cosine over sine. And then for Pythagorean identities, sine squared plus cosine squared would equal 1, and then 1 plus tan squared would equal secant squared, and then also 1 plus cotangent squared would equal cosecant squared. All right, for the acute angle, sine theta would equal 0.6, so also 3 over 5. So for sine, opposite over hypotenuse. So we put our 3 opposite of theta, and then our hypotenuse, long angle, long length, would be 5. So then we go to the Pythagorean theorem, and we'd have this equal A. Our hypotenuse is always C, so we put the C over here. So then 3 squared plus x squared equals 5 squared. So 9 plus x squared equals 25. So then we do minus 9 each side, which would equal 16. So then we have to get x by itself, so x squared equals 16, but then we have to square root it. So square root of x squared equals square root of 16. So then x would equal 4. And then for the acute angle, tan would equal 3. So you have 3 over 1. So tan is opposite over adjacent, so 3 opposite over 1 adjacent. So then to find c squared, you'd have 3 squared plus 1 squared, so 9 plus 1 would equal the square root of 10. All right, so then with all of this, our secant would equal square root 10. And then, so we go down to this one. So a 12-meter flagpole casts a shadow, and then the elevation of the tip of the shadow is 40 degrees. Oh, okay, so 12-meter flagpole right here, our length right here, casts a shadow. So this is the shadow right here. And then the angle of the elevation, so we have to put an angle right here, 40 degrees 15. So then we have to find the length of this shadow. So then we would do tan 40 degrees 15 would equal 12 over x. So then what we're going to do is we're going to cross multiply, and then we're going to solve for x. And once we solve for x, we get an answer of 14.2. So then for this one, a person is 200 yards from a river. So we're going to start right here, and then we're going to go 200 yards for our length right here. So then the person will walk 400 yards in a straight path to the river's edge, which is right here. So the person then walks 400 yards right here. So then we have to find the acute angle right here between the path and the river's edge. So what we're going to use sine, and then we use 200 over 400. So then when we do this, we find that our theta would equal 30 degrees.